Vertical asymptotes, domain, and holes. Pre-college, pre-calculus math. The focus of this video is going to be the holes part of it. We've already discussed vertical asymptotes and domains, but now we're going to add how to find the coordinates of these holes. So we've done steps 1 through 4 already, and we're adding step 5 to it. So we're going to continue to always just build on what we've previously done. So we're still going to find vertical asymptotes. We're still going to state domains, but now we're also going to state those coordinates of the holes. So step 1, factor numerator and denominator. This can be factored to be x plus 3, x minus 3, x plus 3, x minus 3. And the bottom would be, let's see, that would be x plus 5 and x minus 3. And when we did this last, the next step was to simplify here. That's what I have written as step 2. But I think a lot of you were getting a little confused on the fact that some things were crossing out but still in the domain. So if you find it easier after step 1, go straight to step 4. So don't simplify anything yet. State the domain next. And your domain is what would make these things 0. So if you solve this, you get x equals -5 and x equals 3. And yes, I am aware that these are going to cross out, but don't cross them out yet. Solve them first. You get x equals -5 and x equals 3. And it's simply setting them equal to 0 and what, solving for them. Or you could just do it in your head, what would make it 0 type of thing. And once you have those, state your domain. X, these are your restrictions. So we're looking at -infinity to -5. You could have every x is between -infinity and -5. And then all the x's between -5 and 3 also are okay. And then everything between 3 to infinity works. Basically, what we're saying here is the only numbers x cannot be are -5 and 3. So as soon as you factor, don't simplify anything yet. Write the domain with what these things equal, and then go back to step 2 and start simplifying. So the x minus 3's will cross out here. So the fact that what's left over, and you should always rewrite what's left over. What's left over is x plus 3 over x plus 5. Okay. So your vertical asymptote is what's left over on the bottom here, x plus 5, and you could set it equal to 0 if you want, but we already kind of did that over here. Here's my vertical asymptote. Let me write VA next to that. My vertical asymptote is the one that didn't cross out, so x equals -5. But the whole is going to come from the thing that did cross out. So you see how x minus 3 crossed out because it was a common factor with the numerator and the denominator. Now, it was still part of our, it's still a restriction. If you plug in 3 for x into our original equation, you still get 0 down here. So it's still in the restriction from the domain. But because it got crossed out, it is not listed as a vertical asymptote. Instead, it becomes a hole. But a hole is not a vertical or horizontal line like asymptotes are. A hole is a coordinate. And what you found when we solved this of x equals 3, this is the x value of the coordinate of the hole. And what you need to do to find the y value of the hole is plug this x value in to your simplified expression. So what you have is your hole, x equals 3, that needs to get plugged in to the x values of the terms that did not get crossed out. And that would be 3 plus 3 over 3 plus 5 equals 6 over 8. Simplifies to divide everything by 2, 3/4. And that is the y value of the whole. All right, so let me recap all of that. Factor, state the domain. Anything, and it's always helpful to take a second and think, all right, my domain is x squared, which means I'm going to have 2 restrictions on my domain, which will then split me up into 3 intervals. So I got x plus 5, x minus 3, which tells me x equals negative 5 is one restriction, and x equals 3 is the other restriction. So I state my domain. X minus 3 crosses out. What didn't cross out, the x plus 5, which is x equals negative 5, that's my vertical asymptote. We're used to that. The term that did cross out, that's still a restriction on the domain, but that value, which becomes x equals 3, is the x value of the whole. And you get the y value of the whole by plugging that 3 into the terms that did not cross out. That's why we like to rewrite it after we cross out. So what was left after crossing out was x plus 3 over x plus 5. Plugging in our whole x value 3 got us the 3/4. And that is how we do these problems. All right, let me do one more example for you. But that's basically it. All right, so start off here. Let's factor. I could take out a x, and that will give us x squared minus 4, which actually can be factored a second time to be x plus 2, x minus 2. So there's a lot of basic factoring in this. So you got to watch out for it. So that's what that simplifies to. And the bottom, now because this is x to the first, means I'm only going to have one restriction on x. I don't know if it's a vertical asymptote or a whole, but I know there's going to be one restriction on my domain. And so this is a GCF. I could take out an x and get an x plus 2. The 6 that you took out, that doesn't really do anything, but this x plus 2 is going to give us a restriction at x equals negative 2. Again, notice that I didn't simplify yet. I just factored it, and so I could solve what's in there, and that gives me the domain. And really, it comes down to whatever you're most comfortable with. If you're comfortable with first crossing them out, rewriting it, and then doing your domain, but don't forget to include the term you crossed out like we did yesterday, you can do that. Just trying to come up with whatever method you find easier. So, I mean, the order of how you do these first 5 steps really can be in any order. You could factor, then do the wholes, and then simplify, and then do vertical asymptotes. You know, there's a lot of different orders on where you could proceed. So whatever you find works best for you. But negative infinity to negative 2, and then negative 2 to infinity. Now, the simplifying step does cross out this x plus 2. And so that means there are no x's left in the denominator, which means my vertical asymptote is none. You do not always have a vertical asymptote. But there is a hole. Because the x plus 2 crossed out, that's what eliminated the vertical asymptote, but it did then create a hole in the graph. And the hole is going to be at negative 2. The y value is by plugging negative 2 into what's left over. So I need to write down what is left over. Well, what didn't cross out was an x and an x minus 2 up top. They survived. And a 6 on the bottom. So then when I plug in negative 2, I get negative 2 times negative 2 minus 2 over 6. Negative 2 minus 2 is negative 4, so I'm looking at negative 2 times negative 4 over 6. That's positive 8 over 6. Positive 8 over 6, kind of running out of space here. Or can I squeeze that in there? 8 over 6 reduces to, divide by 2, 4 over 3. And it often is a fraction, so that's very common. All right, that's basically it, guys. So you're going to factor, you're going to simplify. If something crosses out, it's the x value, solving the piece that crossed out, like we did here. X plus 2 crossed out, which means x equals negative 2 is the x value of a whole. And I plugged that negative 2 into all the x's that did not cross out and solve to get the y value of the whole. If there are any x terms that don't cross out in the bottom, the denominator, that gets you a vertical asymptote. Like in our first example, this x plus 5 did not cross out. That's why we have a vertical asymptote at x equals negative 5. In the second example, all that did not cross out on the bottom is a 6. It's not a variable term, so that's why it does not give us a vertical asymptote. All right, so we'll certainly practice all of this tomorrow, and then the next day we're going to add a step 6 to it, horizontal asymptote. So we're going to build upon this. All right, see ya.